Hello viewers, welcome back to this section of my tutorial, and I'm undertaking an intensive calculus course. This happens to be calculus 2. So the beginning of this course, I'm going to introduce you to intervals. Then you have bounded and unbounded intervals. Kindly watch all videos in this course so that you get the full understanding of the calculus course to aid you in your examination as well as any form of test you take. If this is your first time visiting this channel, kindly press the subscribe button and don't forget to turn on the notification button so that you get notified when I post the subsequent courses as well as the various tutorials I'm going to do on this course. Kindly watch this video to the end and don't forget to like. So, in calculus, we use intervals a lot. Yes, so I'm going to enlighten you about what intervals are. When you say intervals, what are they? So basically, when you say interval is a distance, or you say that it's just a period depending on the two parameters we are dealing with. So if we are dealing with 2 points, we say an interval is the distance between the 2 points. So let's see. Way back in high school, when you are using Cartesian plane, or when you are doing your plane, in this plane, we have our y-axis, we have the x-axis, we have something we call a point or a coordinate. So we represent it with a, b. Yes. So this is a point in coordinate. Now, this bracket we have here has significance when we are doing calculus, and that is what we are going to take note of. So first of all, intervals in calculus, what am I saying? So first of all, given any two numbers a and b, where a is less than or equal to b, so meaning a is a smaller number and b is a bigger number, or the two can be equal. So let's see, given these 2 points as my endpoint, I can have an interval between these 2 points. So if I have the lower point and have the maximum point, and that will be my interval. In this course, we consider what we call the open and close interval. Now, when you say an open interval, we represent it with a smooth bracket like this and like this. That is what we call an open interval. So whenever you see any two numbers, say 2, 3, in this open interval like this, don't think it's a coordinate, but rather it's an interval where we have 2 at the lower point and 3 at the upper point. So an interval is simply the whole numbers, or the numbers that fall between 2 and 3 on the number plane. So take note, when you see this smooth curve, it is an open interval, not a coordinate when we are using calculus. So let's check the other type, which is closed interval. We represent closed intervals in calculus with an angle bracket like this. So when we see an angle bracket, we say that we are using closed intervals. Closed intervals. So if you see angle bracket 2, 3, this is what a closed interval where we have 2 as the lower point and 3 as our upper point. Now let's move ahead, considering the mathematical representation of these open and closed intervals. So let's see, if you have an open interval, say open 1, 5, the mathematical representation in calculus is simply equal to 1 less than a number, let's say x less than 5. So this is an interval in which we have x greater than 1 and x less than 5, where 1 and 5 are excluded. Where 1 and 5 are excluded. So meaning the endpoints 1 and 5 are not included. Now let's see closed interval. If I have closed interval 1, 5, then what this implies is I have 1 less than or equal to x less than or equal to 5. So meaning 1 and 5 are included. So that's the two main difference between a closed interval and an open interval. In the mathematical representation, we introduce the equal to sign, but when you are dealing with open, it's not, the end points are not included. Now let's see other types, which we call half open. Half open. Now for the half open, as the name denotes, it's either half open or half closed. For that one, I'll have a smooth curve 1,5, then I have a closed. So the mathematical representation of this is going to be what? 1 less than the number x, then less than or equal to 5. Take note, where the closed is, we put equal to under the less than sign. So this is how we deal with intervals, open and closed intervals in calculus. So let's move straight to bounded and unbounded intervals. So when you say bounded and unbounded intervals, as the name says, basically when you say something is bounded, meaning that something has been fenced, or we have some kind of barrier. Yes, let me use the word barrier. So bounded intervals have limits or have bounds which you can't exceed, and for that reason we have the lower bound, we have the upper bound. Exactly. So what are the bounded intervals we have? A bounded interval can be an open interval a comma b, then it can also be a closed interval a comma b. It can also be a half open a b like this, or it can also be like this, a comma b. So all these intervals are said to be bounded because it has a lower limit here which you can't cross, it has an upper limit here which you can also exceed. So that is bounded intervals. Now I want to ask, what are unbounded intervals? So let me indicate this is bounded. What are unbounded intervals? So when you say unbounded intervals, this is the introduction of infinity. Yes. So if you have an interval where if any of the ends or both ends are the infinity symbol or the infinity, then we say your interval is not bounded. So let's see an example. We can have negative infinity here, comma a. What this implies is that you are going to start from negative infinity to a, meaning this one is not bounded because here negative infinity has no limit. Then here it has a limit here, which is our upper bound. So this one is it's a right bounded. So this is right bounded interval because the right side has an upper bound, but the lower side is infinite. Now let's see another type of unbounded. We can have a comma positive infinity, and this one is also a left bounded, so meaning it's on the left side which has a lower limit, but here is infinite. Then finally we have a complete unbounded, which is negative infinity to positive infinity, and this is a complete unbounded interval. Yes. Now we can go ahead and write the mathematical representation for each. So this is going to be negative infinity here, less than x less than a because it's open. Take note, you can have a which is here, then I can have less than x less than positive infinity, then finally I can have negative infinity less than x less than positive infinity. Now let's take notes. Whenever you introduce an infinity sign in an interval, it's strictly entitled to an open interval. You can't use a closed interval to close an infinity sign. So that is what you are supposed to take note. Thank you. This is the end of this section. Then watch out. I'm going to post the rest of the courses. Stay tuned. Follow this course and you're going to understand calculus to the basic level. Thanks for watching.